Hello, and welcome to another installment of Algebra 2. This is section 2, and this is a section about the standard form of a quadratic function. Okay, and we want to be able to graph a quadratic function given in standard form, identifying key features of the graph. So, there are a few things that are very important here that we can find given any equation of a quadratic. We can find the vertex, okay, and this is often called the maximum and min, okay, and or minimum, and slash or minimum. Okay, the x-intercepts, that's where the graph crosses the x-axis, okay, and then the y-intercept, that's where the graph crosses the y-axis, okay. And so these are things that we'll be able to kind of figure out given a graph or given a quadratic function. Before we move on and kind of look at a few things, I do want to talk about the coefficients of a quadratic. Now, and whenever we write a quadratic of the form f of x is equal to ax squared plus bx plus c, okay? Where a is your leading coefficient. Leading coefficient. Okay, and when I say coefficients, those are numbers in front of the variables. Okay, and so that's our leading coefficient, a, and that's next to the x squared. So next to the x squared, okay? The b is the second coefficient, and the b is our second coefficient, okay, second coefficient, and it's always next to the x, okay? And then we have our last one, which is our c coefficient, all right, and this is our just constant, okay? We also call that the constant, and that's where there's no x, okay? So if there's no x, then that's our value for c, okay? So it's important that we know what those constants are, or those coefficients are and constants, because we'll be using them quite a bit, okay? Now, back to what we were talking about with a parabola. Let's say we have the situation here where we have a high school football kicker that punts the ball, and the ball's trajectory follows a path that can be modeled by this function, negative 9.8x squared plus 28x. And so the ball, goes up, and then it comes back down again. All right, and what we see here is we see that we have a maximum height right here. All right, and I'm going to call this, I'm going to put it in red, I'm going to call this the vertex, okay? And the vertex has the maximum height, okay? And that's going to come into play later. And then notice that our x-intercepts right here, so our x-intercepts, is where the height of that height of the ball, height is 0, okay? Now the other thing I want you guys to see here is that if I were to draw a line going from my vertex all the way down the middle of the graph, what I notice is that this graph is symmetric, meaning that all of the points from here to here are equidistant, okay, and all the points here and here are equidistant. Same thing here, equidistant and equidistant, okay? And so this axis of symmetry, okay, axis of symmetry is important because it gives us that information, okay? Because we have, on either side of the axis of symmetry, the x values are different, but the y values are the same. Same thing here. X values are different, but the y values are the same, all right? So this is just some of the properties that we have of a quadratic function. Now, right here in both examples, we showed that we had a maximum wherever our vertex was, okay? So sometimes we can have both a maximum or a minimum, okay? Here, we have a maximum, okay? in here we have a minimum. Now notice something here, is that when our leading coefficient, when we have a maximum, our leading coefficient, that value for A, when we have a maximum is negative, and when we have a minimum, the leading coefficient is positive. So here, all right, to get a minimum, so I'm going to zoom in here, and a minimum is produced when the leading coefficient, okay, which is also known as A, is positive, okay? So that means that the graph opens up, okay, like this, and it's going to produce a minimum. Okay, when over here, we're going to get a maximum. So a maximum is produced, max is produced when my value, so when your leading coefficient is negative, okay? And that's what we see here, is that negative value, okay? Leading coefficient, and that's the same thing as saying our A value, okay? All right, so what I want to do is identify, which one of these has a minimum value vertex, and it's pretty easy, okay? You look to see, that we're go from increasing to decreasing, increasing to decreasing, increasing to decreasing. Okay, so we have a maximum here, here, and here. This parabola goes from decreasing to increasing, so this one gives us a minimum. Okay, that's a minimum, so it's this one, all right? Now, what we want to do is figure out how to calculate a vertex and an axis of symmetry. So the way that we would do this, and we use this thing called opposite b over 2a, okay, and so we have to use the coefficients of a quadratic function in standard form to be able to do this. So if I were to find the vertex, okay, of that point, that means that x is equal, the x value, opposite b over 2a. This will give us the x value of our vertex. So the x value of our vertex, okay? If we wanted to find the y value of our vertex, we simply just find f of opposite b over 2a. And this gives us our y value of the vertex, all right? And then to find our axis of symmetry, it's the same thing as just saying x equals opposite b over 2a. Okay, and I'll kind of show you that here in a minute. All right, so find the axis of symmetry for the function 2x squared minus 6x plus 3. So the first thing I want to do is identify what my a value is. A is 2, okay, b is negative 6, and c is 3, okay? And so we know that our axis is opposite b, so the x value is equal to opposite b over 2a. So to figure this out, okay, opposite b is negative 6. So the opposite of b, all right, so let me write that out. So b is equal to negative 6. A is equal to what, 2? Okay, so x, so if I did opposite b, okay, opposite negative 6 is going to be positive 6, okay? Over 2 times a, well, 2 times 2, all right? And so this is going to give us 6 over 4. So then we get that x is really equal to 3/2, okay, or 1.5. All right, so this is the x value of our vertex. So this is the x value of the vertex, and this is also the axis of symmetry, okay? It's a vertical line. So now, what I want to do, in order to find the y value of my vertex, I want to plug in 3/2 into my function here. So I'm going to do this. I'm going to do f of 3/2, and let's just do 1.5, and let's just plug it into the calculator. So I'm going to do 2 times the quantity 1.5 squared minus 6 times 1.5, and then plus 3, okay? So give me a second. Let me put that in the calculator and evaluate. And after evaluating, okay, I'm going to get a value, okay, and all I did was just do all the math here, okay, and I get a value of negative 1.5, okay? So my vertex, okay, vertex is at the point 1.5 comma negative 1.5. Now let's just go ahead and graph this, and I'm going to graph the axis of symmetry as well. So give me a second, I'm going to go to Desmos, plug all this stuff in, and be right back. Okay, so if I take a look at this, what I notice is once I graphed my parabola, okay, it opens up. I just went down to the very bottom point at my vertex and found that I have the same thing that we found algebraically, okay, 1.5 comma negative 1.5. And then I actually graphed the line x equals 1.5, okay? So this line is a vertical line, okay? When you have x equals a number, this is a vertical line, okay? And that's what we got, okay? So just wanted to double check that we get the same thing and go from there. Okay, on the next page, it actually gives us the same thing. Gives us the answer and shows us what we did, and we did a good job. Okay, so now, let's go ahead and let's do the same thing here. Let's calculate the vertex of a function. Now what I want to do is I'm going to label my a value, my b value, and my c value. Now if there is no coefficient there, okay, if there's no number there, then my a value is equal to 1. So a is equal to 1, b is equal to negative 8, and then c is equal to negative 9. Okay, so we want to know what's the vertex of the function. Now for me to find the vertex, I have to use the formula x is equal to opposite b over 2a. Okay, so I'm going to do this. I'm going to do x is equal to opposite b. Now b is negative 8. So opposite negative 8 is going to be positive 8. Okay, and over 2 times a is 1, so 2 times 1. This gives us a value of 8 over 2, which gives us a value of 4. So we get x is equal to 4. Okay, and this is the x value of the vertex. So x value of the vertex, and it's also the axis of symmetry. Okay. Now the next thing I want to do is I want to find the y value when x is 4. So I'm going to find f of 4. All right, I'm going to plug that in. So then we get the quantity 4 squared minus 8 times 4, and then minus 9. Okay, and so then f of 4, if we continue to evaluate this is 16. 4 squared is 16 minus 32 minus 9. And so let's see what that gives us. 16 minus 32 is negative 16. So negative 16 and then minus 9. That's going to give us negative 25, I think. Yep, negative 25. So f of 4 is equal to negative 25. So this right here is the y value of the vertex. Okay? And so then we get this. Then we get the point, okay, the vertex is the point 4 comma negative 25. Okay? And that's all we're doing there. Okay, let's take a look over here. Let's, on this one it says we want to analyze a parabola. So let's first identify the vertex. Okay, the vertex is down here at the point 0, negative 9. So 0, negative 9. Okay, the domain of this parabola is going to be all real numbers. So it's going to be all real numbers. Okay, and we can write that in interval notation as negative infinity to positive infinity. Okay, the range is the set of y values, okay? And we know that the set of y values are going to be larger or equal to negative 9. Okay, that's the smallest y value. So I can say this. I can say y is greater than or equal to negative 9. Okay, or I can write this in interval notation and say negative 9 to positive infinity. Okay, now where are we increasing? Now when it says intervals of increasing, this wants to know for what x values are my y values getting larger. So right here, okay, this is where we're increasing. Okay, the y values are getting bigger. And this starts at an x value of 0 and goes to the right. Okay, so what we have is I would say that this goes from 0 to positive infinity. Okay. Okay, so then we want to talk about where we're decreasing and where the y values are getting smaller. Okay, and we want to say, okay, for what x values is this happening at? And so those x values start at negative infinity, and they go all the way to 0, and that's it. So, and let me highlight that, okay? You know, when I talk about that, you know, let me use a highlighter. You know, this is where the function is increasing, okay? That's where we're increasing. Here are the x values for where we are increasing, okay? When we start at 0 and we go to positive infinity, that's what I'm talking about. I'm talking about these are the values from 0 to infinity where the y values are getting larger, okay? So we have to talk about both of the x values and the y values. Okay, same thing with having a decreasing function, okay? That's happening over these x values, okay? So from negative infinity to 0 is where our x values are getting smaller, okay? And that's it. Okay, here our vertex, vertex is here at the point 0, 4. Okay, our domain goes from negative infinity to positive infinity. That's where our x values go. And that's going to be true for all parabolas. Okay, but our range goes from, you know, negative infinity. So I'm going to say negative infinity to 4. Okay, and actually we include 4. So we need that. Okay, we could also say that y is less than or equal to positive 4. Okay, that works too. Either one of those works. I think that's it for that page. Okay, so again, going back to the idea of increasing and decreasing intervals. So which statement is true regarding the intervals where the function is increasing and decreasing? Well, let's just talk, you know. Okay, here's where our function is increasing. Okay, the y values are getting larger. This is where the function is decreasing, and then we have a maximum right here. Okay, we have a max. Okay, not to be confused with Mr. Boothie. Okay, then what we have is, you know, we want to know where is this increasing. So we are increasing on the intervals from negative infinity to 0. Okay, and then we're decreasing from 0 to positive infinity. Okay, so I'm going to write that. Okay, that we are. Here we're decreasing from 0 to positive infinity, okay? And then we are increasing from negative infinity to 0, okay? So let's take a look here. It says the function is increasing from negative infinity to 0, okay? That's true. Okay, the function is increasing from 0 to infinity, that's false. Okay, the function is decreasing from negative infinity to 0, that's false. And we are decreasing the whole time, that's false. So the first one is the only one that's true, okay? Now, if we wanted to graph parabolas, okay, we already know how to graph the vertex, but then we need to be able to graph the x-intercepts, if there are any, and then graph the y-intercept. Now, in order for us to graph the x-intercepts, okay, that's the value where the graph crosses the x-axis, okay? And the y value at that point is 0. So if I were to plot each of these intercepts here, this is the point negative 4, 0, and this is the point, say, 2, 0. Okay, notice that the y values are 0, okay? And what we're going to do, and guys, any point on this, if I'm having you find the x-intercepts, the whole point of this chapter is to figure out where those are. But we have to do it algebraically towards the end of the chapter. Right now we haven't learned that yet, so all I would do is I would have you guys you know, graph this and just look at the graph. Okay. Now the other thing is a y-intercept. Okay, and the y-intercept is right here. Okay, this is my y-intercept. And this is the point 0, 8. Notice that the x value of my y-intercept is 0. Okay? Now, the other thing I want you to notice is that the value here, 8, is also your y-intercept. Okay? If you plug in 0 in for x, then you're just going to get 8 as a y value, and that's what we're looking for. Okay? So that's all I've got for that. All right? Now, it says, consider the function x squared plus 12x plus 11. It says, what are the intercepts of the function? So what I'm going to do is I'm going to go into Desmos, I'm going to graph that sucker, and we're going to figure it out. Be right back. All right, so what I've done on this one is I've graphed this, and I've located the x-intercepts and the y-intercept. Now the y-intercept you can just tell because of this number here, okay? That's going to be your y-intercept always, okay? Y-intercept is your c value. Now what I want to do is also note these values here. So the x-intercept is the point -11, 0, and the point -1, 0, okay? And those are the values that make the y value 0, okay? That's where the x-intercept is, okay? And that's all we're doing, okay? So, all right, answer that question. Okay, graphing a quadratic function. So let's do this, okay? We've got the graph x squared minus 2x minus 3. Let's take a look at the vertex first. So let's do this. Let's label this as A, B, and C. Okay, so A is equal to 1, B is equal to -2, and C is equal to -3. Okay, so what I want to do is I want to do x is equal to opposite b over 2a. So x is equal to opposite b, which is -2, so opposite of -2 is +2, over 2 times a, which is 1. So x is just equal to 2 over 2, which is equal to 1. So not only is x equal 1 the x value of my vertex, but it's also the axis of symmetry. So my axis of symmetry is the line x equals 1. Okay? The next thing I want to do is I want to plug this number into my function to find the y value of that vertex. So if I did f of 1, it's going to give me 1 squared minus 2 times 1 minus 3. So this gives me 1 minus 2 minus 3. So we get 1 minus 2 is -1 minus 3 is -4. Okay, so this is the y value, okay, of my vertex. So my vertex is the point 1, -4. Okay, now what I want to do is I'm going to go ahead and just graph that over here. I'm going to do 1, -4. Okay, and plot that point right there. Okay, my axis of symmetry, I'm also going to draw that like this. Okay, now to find my y-intercept, okay, that's going to be the value of c is -3. My y-intercept is the point 0, -3. Okay, now here's what I've got. Here's what's kind of easy about this, is I've got this point here, 0, -3. I know that this point is also reflected over my axis of symmetry, right here. Okay, and so then if I draw my graph, all right, get this here, get that here, all right, get this parabola, then I realize that I have a point here and a point here, and these are my x-intercepts, and that would be the point -1, 0, and this would be the point 3, 0. Now let's just graph this function real quick, and let's just verify that we do in fact have those. So let me write those down as -1, 0, and the point 3, 0. Okay, let me graph that real quick, and I'll be right back. Okay, and after I've graphed it, here is our vertex, here's our y-intercept, that matches what we have. And then here are my x-intercepts at -1, 0, and 3, 0. So we do match what we had here. Okay, this is the same graph, but we just wanted to verify by graphing. So do verify on Desmos when you do this stuff.